Okay, now you know very well what is the electric potential energy of a particular system. You know very well here a particular charge capital Q as well as a charge small q will make a particular system, and electric potential energy of that particular system was derived and just written as the U equals to work done. W is written as the 1 upon 4 pi epsilon naught QQ by R. So now before introducing what is electric potential difference, I want to introduce you what is the electric potential. What is the difference between the electric potential energy as well as the electric potential? Potential energy is the energy and potential is the property of a particular point in electrostatic region. In that particular electrostatic field, electric field, it is a property of a particular point. So now you know very well, it is given here. It is bringing a charge from infinite small q charge from infinite to point P. Suppose if value of the small q is the 1, it means unit. Okay, unity, its value is unit. And what will be the value of that particular potential energy? It becomes 1 upon 4 pi epsilon naught capital Q divided by the R. And that particular term is known as the potential of a point P due to that particular charge capital Q. Okay, mean to say, if you will bring a unit charge from infinity to that particular point, then it must to be known as the electric potential of that particular point. And therefore we can say what is the electric potential? It is known as the work done to bring a unit charge from infinity to that particular point. And what is the potential difference? It is the potential of a particular point, which is suppose that known as the B minus potential of a particular point, which is known as the point A. Mean to say, it is a potential difference between the two different points is known as potential difference. Simple. And now I want to introduce you how we will derive the formula, which is electric potential difference due to a particular point charge. Okay. So now you know very well here it is given that all the figure is similar, but I am just choosing here. It is a charge, source charge capital Q, and from that particular charge a point R is given, which is R1 distance from it. A point P is given, which is R2 distance from it, and a point A and B chosen, which are infinitesimally small distance apart, and both are at a x distance from the source charge. And it is a just boundary region behind which we can consider infinite region. And you know very well, electrostatic force at this one region will applied by source charge will be towards to the infinity. Repulsive force will be outward. And if you want to bring a charge from infinite to that particular point, you will do external work. External work must be done by the source. External work must be done by the external agent to bring a charge from infinite to that particular point. So now I want to find the potential difference between these 2 points. It is totally similar to the derivation as we was done at the previous part of it. Please say, suppose capital Q, you know very well what is it, a small q. In place of the small q, I am choosing a particular test charge. It is unit positive test charge. Okay, and now I want to calculate a small work done dW, which must be again given as the F electrostatic into dx with negative sign as was derived at the previous part of it derivation. So you can find the result. Again you will write here electrostatic force at a particular point A or B is given as the 1 upon 4 pi epsilon naught capital Q small q naught, because we want to bring a charge, test charge here q naught. You know very well it must be given as the x square, and when we will put the value it becomes minus 1 upon 4 pi epsilon naught q naught divided by the x square is the force, and it is the dx multiplied by the dx. Then what will be the work done? Total work done. Therefore total work done W can be written as the integration of the dw. Whole of the derivation is similar to the previous derivation, but here what is the slightly difference? You know very well, when we will integrate it, we will put the value of that integration 1 upon x square dx, and just want to find the potential difference between the point P and point R. You know very well it is at the R2 distance from the center of the charge, and it was at the R1 distance from the center of charge, and R1 is less than the R2. It is given according to the figure. So you must bring the charge from R2 to R1, and you will integrate it from R2 to R1. Okay, you are bringing the charge from P to R. So now what will be the work done? It must be known as, when you will integrate it, its value becomes 1 upon 4 pi epsilon naught capital Q, Q naught, and it must be given as the 1 upon X, and it becomes R2 to R1. It was minus and it was minus, both the minus just becomes plus, positive. And now it can be written as the 1 upon 4 pi epsilon naught Q, Q naught, and when we will apply the head and lower limit, it becomes 1 upon R1 minus 1 upon R2. So therefore, what will the potential difference? It is representing by the delta V, must be given as the work done to bring a particular charge, test charge, from point P to point R, divided by the test charge, and finally its result becomes 1 upon 4 pi epsilon naught capital Q, and it will be written as R1 minus R2. When we will multiply it, you know very well it becomes 1 upon 4 pi epsilon naught Q upon R1 minus 1 upon 4 pi epsilon naught Q upon R2. And finally it can be written as the R1. It is the distance of the point R. So it becomes VR minus VP. Therefore you can say potential difference V is the difference of the potential of these 2 points. Okay. So finally you will find the result of that particular derivation, and you will get the result in volt. At last I want to introduce you a third derivation which is just similar to that particular derivation. It is similar to the previous, and the third derivation, if we want to find the electric potential at a particular point, what will be the difference between them? If you want to find the potential of point P, suppose point P is situated at a particular distance. Suppose in the previous article, you want to find the potential of that particular point P, which is R distance from the source charge. Then how you will find the result? Please see here, you are just integrating it from distance R2 to R1. And here if you want to find the potential of the point P, then you will integrate that particular term. You know very well, we are just applying the result. So that particular term is just taken as the, I am just removing that particular portion of the derivation. Okay. And that particular result will be taken as, please see. Here I want to clear here. You know very well, work done is known as the 1 upon 4 pi epsilon naught, and it will be Q, Q naught, and it was the minus 1 upon X, but proper limit, what was the limit? Limit is infinite to R, because if you want to find the potential of the point P, you must bring the test charge Q naught from this one point to point P. Okay, why I am choosing test charge? Because it will must be always unit positive, and test charge because we want to find the potential. So you know very well, potential of point P is written as the work done to bring a charge from infinite to the point P per unit test charge. Per unit charge is written as the 1 upon 4 pi epsilon, because that particular minus and that particular minus will multiply and just give the result plus, and it must be written like that, Q upon R. Just putting the higher value and lower value of it. You know very well, if you want to write in the same manner, it can be written as the 1 upon R minus 1 upon infinity. And 1 upon infinity is known as 0. So you know very well here, it becomes 1 upon 4 pi epsilon naught, and it becomes Q by R. What is it? It is a potential of a particular point due to a point charge. Okay. I want to say you, all these derivations are similar. If you know what is the basic fundamental of that particular potential energy, then you can easily calculate the potential difference. And if you know what is the potential difference between these 2 points, then you can easily calculate the potential due to a point charge at a particular point. And it is very simple to understand. Okay, so after all, I will discuss after next video. I will discuss what is the relation between the electric field and potential. But up to here, you must be complete the concept so that it becomes more easier for you to understand. Okay, thank you, Tara. Okay, now after completing of that particular part, potential due to a point charge, now I will discuss relation between the electric field intensity and the potential. Electric field was vector and potential is a scalar term to represent the electrostatic region surrounding to a particular charge, and it is also known as the potential gradient. Okay, so again in similar previous condition, you know very well, at the condition, you know, we are choosing a source charge capital Q and it is a infinite up to the infinite. That particular region is infinite. That is the region, electrostatic region of source charge capital Q. And suppose I am choosing, there are 2 different points P and R. They are small r distance from the source charge and they are very close to each other and infinitesimally small distance dr apart. You know, in that particular electrostatic region, a particular test charge which is just bringing from infinite to that particular point, that particular any point inside of electrostatic region, it is a unit positive, it is test charge, which is positive and unit always. Okay, so here point P is at a r distance from the charge capital Q. Then what will be the work done due to external agent? You know, okay. Here, what will be the work done? So, a small work done dW is written as the F external into dr, and that particular external work done, you must be bring charge along with that particular direction, so you will do work, and F external will be directed here, and it will be written as the minus F electrostatic and dr. Okay, so now you know very well, we want to find the relation between the electric field and potential, then we will find electrostatic force in the terms of electric field, and it must be given as the E into Q naught as studied at the previous chapter. And you know very well, force is also written in that particular manner. So therefore it becomes dW is written as the minus of the E Q naught into dr. Okay, and now you know very well what is the potential. You know it is a work done to bring a unit charge. Mean to say, divided Q naught, dW divided by the Q naught, it becomes minus of the E into dr. So what will be the result finally? We will get the result, it is the minus E into dr. Okay, and finally we can write here E equals to minus dV over dr. And that particular relation is known as the potential gradient Newton per Coulomb or volt per meter. It is known as the potential gradient. And I want to introduce a particular important term here in the terms of note. That particular negative sign, what is the significance of negative sign here? It is a negative sign indicating when we will move, along to intensity of electric field. Okay, potential always decreases. Very important concept here. What do you mean by it? If we will move along to the electric field, potential must be decreases. Suppose I am choosing here a positive charge, and you know very well, due to the positive charge, electric field must be directed like that. And suppose I am choosing these 2 different points, point A and point B. You know very well, it is a direction of the electric field or not? It is a direction of the electric field. And when we will move along to the electric field, always potential decreases. Mean to say, potential of the point A will always be greater than the potential of the point B. Mean to say, potential of the point B will always be less than the point A because it is along to the electric field. Okay.